A few years ago, when I first began experiments, I was fairly impressed with the detail of craters that were formed. Images of craters in the solar system would run through my mind. The only problem was the ability to record the detail. The solution has been found in a new chamber. In that chamber, electricity performed well, producing analogs of atmosphere-deprived bodies. Observing images side by side with counterparts in the solar system demonstrates the ability of plasma to produce complex structures as well as other anomalous formations. Craters will vary in diameter and can be as large as 300 kilometers across. The depth of craters, however, increases little with diameter, depths being up to 5 kilometers. In these low-pressure experiments, vapors being removed from the surface seems to be the cause of the flat interior of the crater. These craters also show signs of collapsing terrain at the wall of the crater. The image on the left producing a terraced wall, and the image on the right shows a more dendritic ridge from collapse. Either is found in the solar system. Collapsing can also produce scalloping. Formations that both contain multiple craters with relatively flat floors. Notice that the ejecta is also similar in both formations. Formations that are both chains of 3 craters. The craters formed close together and retained distinct rims rather than a flat floor. The features on the right were produced by soil that contained moisture from a previous day's rain. With a large flat floor, collapsing occurred throughout the discharge. Multiple layers with the central pit and collapsing causing dendritic and scalloping features on the outer wall. Reading some notes taken from Wikipedia, quote, "Complex craters are a type of large impact crater morphology. Above a certain threshold size, which varies with planetary gravity, the collapse and modification of the transient cavity is much more extensive, and the resulting structure is called a complex crater. Complex craters have uplifted centers, and they have typically broad, flat, shallow crater floors and terraced walls. On icy as opposed to rocky bodies, other morphological forms appear, which may have central pits rather than central peaks. Collapsing around the circumference, flat floor, central pit. These are features of a complex crater. With comparisons of these craters being so close, one might suggest that both craters are complex craters. I have yet to see such a close resemblance as this among high-velocity impact experiments. I should mention at this stage in observation, I have not produced a central peak or a peak ring. I'm uncertain if maintaining the discharge would produce a central peak. There are formations that rise up from the cathode and will begin to push out of the surface. For reasons of temperature, I typically terminate the voltage to protect the chamber. Perhaps in a larger scale, these formations could rise from the surface and collapse under gravity, producing peaks of highly porous material. It has been shown that high-velocity impact experiments can produce varying features of complexity, but fail to produce a coherent complex structure. These formations are the result of launching projectiles at granite blocks. They have central pits, but lack the flat floor and collapsing features. This crater has some collapsing features around the rim, but most of the ejecta fell back into the crater. We don't see a flat floor, but a bowl shape. These are the result of projectiles launched at iron-nickel ingots. These experiments are being used to study impacts on extremely dense asteroids. There is a planned mission for 2026 when we will arrive at one of these types of asteroids. The composition of the dense asteroids should change the formations for both theories, and so the acid test will be laid down. I think that if the craters are electric, there will be less craters on a more conductive object. Impact theory possesses an inherent randomness, but cratered bodies do not show inherent randomness. This is made apparent by the hypothesis known as the Late Heavy Bombardment. The heavy bombardment fixes the number of impactors to match what is seen on cratered bodies. From our understanding, the formation of a complex crater has never been observed. Therefore, fixing the number of impactors relies on events we haven't seen to explain something we don't understand. It's still an idea. On the contrary, if electric discharges can occur naturally at a scale that produces large complex craters, then discharges mitigate inherent randomness and the necessity for a heavy bombardment period by suggesting localized events are the cause. Of course, discharge formation also lacks a source for these localized events. I wish I could truly witness a complex crater form. Even if they form via impacts, it would be nice to know the exact truth. After searching craters far and wide, learning both sides, I've learned a lot from talented, hard-working people who have committed a large effort into researching this subject. Depending on the level of thoroughness, even if many craters were indeed formed electrically, their work is still incredibly valuable. Maybe time will tell. I feel because of their nature, craters will continue to remain enigmatic. But the fact remains, we don't see these processes anymore. We have close analogs with plasma, but we can only look at the massive scars and wonder.